Next topic is bounds. To describe all the possible values that a rounded number could be, we use bounds. Upper and lower bounds. The lower bound is the smallest value that would round up to the estimated value, while the upper bound is the smallest value that would round up to the next estimated value. The bounds for the number x can be written as lower bound is less than or equal to the number x and less than upper bound. Keep in mind that the lower bound is included in the range of possible values for x, while the upper bound is not. Working with bounds. To calculate upper and lower bound of a number x. For upper bound, add on half the degree of accuracy. For lower bound, take off half the degree of accuracy. Write the number as lower bound is less than or equal to x is less than upper bound. Bounds of a calculation. For addition, if you are adding two numbers together, x equals a plus b, the upper bound of x can be obtained by adding the upper bounds of a and b together. The lower bound of x can be obtained by adding the lower bounds of a and b together. And for subtraction, if you are subtracting a number from another number, for example, it is x equals a minus b, the upper bound of x can be found by subtracting the lower bound of b from upper bound of a. And the lower bound of x can be obtained by subtracting the upper bound of b from the lower bound of a. Multiplication. If you are multiplying two numbers together, x equals a times b, the upper bound of x can be obtained by multiplying upper bounds of a and b together. The lower bound of x can be obtained by multiplying lower bound of a and b together. And for division, if you are dividing a number by another number, for example, it is x equals a divided by b, the upper bound of x can be obtained by dividing the upper bound of a by lower bound of b. The lower bound of x can be obtained by dividing the lower bound of a by upper bound of b. Worked example. Priya has 50 identical parcels. Each parcel has a mass of 17 kg, correct to the nearest kilogram. Find the upper bound for the total mass of 50 parcels. Now degree of accuracy is 1, half the degree of accuracy. So 1 divided by 2 equals 0.5. For upper bound, add on half the degree of accuracy. So 17 plus 0.5 equals 17.5. And upper bound for the total mass of 50 parcels equals 50 times 17.5 equals 875. So the answer is 875. This is the upper bound of the total mass of 50 parcels. Examination tip. Always double check your work before submitting your answer. Check your calculation of bounds to ensure that it is correct and makes sense in the context of the problem. Now test yourself. Question number 1 is, calculate an estimate for this number, state with a reason. Whether the estimate is an overestimate or an underestimate. It's a 2-mark question. Question number 2. The sides of a regular hexagon are 80 mm. Correct to the nearest millimeter. Calculate the lower bound of the perimeter of the hexagon. Here the degree of accuracy is 1. It's a 2-mark question. Next is question number 3. P equals 2 into W plus H. W equals 12. Correct to the nearest whole number. H equals 4. Correct to the nearest whole number. Work out the upper bound for the value of P. It's a 2-mark question. Question number 4. The length of the side of a square is 12 cm. Correct to the nearest centimeter. Calculate the upper bound for the perimeter of the square. It's a 2-mark question. Jo measures the length of a rope and records her measurement. Correct to the nearest 10 centimeters. The upper bound for this measurement is 12.53 meter. Write down the measurement she recorded. It's a 1-mark question.